every single year, the New York State Algebra Regents hits you with the same type of question. The 6-credit question on at least the past 10 Regents exams have all been on the exact same topic. So in this video, I'm going to walk you through some 6-credit questions from the most recent exams so you can see for yourself just how predictable and passable the Algebra Regents actually is. So stick with me. By the end of this video, you're going to know how to lock in those 6 points that could be the difference between passing and having to retake it. So the topic that is almost guaranteed to show up as a 6-point question is a word problem on systems of linear equations. So let's jump right into some real Regents examples, and I can show you how to get a full 6 credits on them. All right, let's start reading and highlighting important information. It says Anna plans to spend $30 on balloons and party hats for her daughter's birthday. Including tax, balloons cost $2 each. Party hats cost $1.50 each. The number of party hats Anna needs is twice as many as the number of balloons. If X represents the number of balloons, Y represents the number of party hats, write a system of equations that can be used to represent the situation. When we are asked to write a system of equations, it means that there are 2 unknowns, there are 2 variables, and we are going to write 2 equations so we can eventually solve for these 2 variables. So we're going to extract the most important information from these word problems and then translate that into math. One of the most important notes that I see here is that the cost of balloons plus the cost of hats is $30. I'm getting that from this highlighted blue part right here. It says she spent $30 on balloons and hats. Well, that means that however much the balloons cost plus however much the hats cost together equals $30. Now I have to translate this into math, into algebraic expressions. So the cost of balloons. Well, one great thing is the problems always give us what the variables represent. So use that, read that carefully. It says that balloons, the number of balloons are represented by X. So if the number of balloons is represented by X, and I know that the balloons cost $2 each according to this problem, well then the cost of all the balloons I buy is going to be 2X because you're going to multiply however many balloons you buy, X, by 2 because they're $2 each. So if I bought 5 balloons, $10. 12 balloons, $24. You're multiplying the number of balloons, X, by 2 to find the cost of all the balloons that you bought. Then I have to add that to the cost of the party hats. The party hats, according to the green highlighted annotations, are represented by Y. So Y is the number of party hats. According to my blue annotations, they cost $1.50 each. So that means if I multiply $1.50 times however many hats I buy, that'll give me the total price of all the hats that I bought. And when I add all of that together, I get 30. And so just like that, I already have, here highlighted in green, the first equation for my system of equations. The second important piece of information I see is that the number of hats is twice the number of balloons. And I'm getting that from this yellow highlighted note from the problem right there. So we just have to read carefully to solve these right. So now let's go ahead and translate that into math again. The number of hats. How do I represent the number of hats? Well, I read very carefully and I see that right in the problem, it tells me Y represents the number of party hats. So this part is very simple. That's just Y. Y is the number of party hats. Done. The number of party hats is equal sign twice. How do you find twice of something? You multiply it by 2. So twice the number of balloons. Well, how do we represent number of balloons? Again, looking back at that green highlighted part in the problem, we just have to read. Number of balloons was X. So I'm doing 2 times X. This says twice the number of balloons is equal to the number of hats. And so just like that, I have already built the second equation that's in my system of equations. And you have 2 points already to start with in this 6-point question. So let's move on and figure out how to get the rest of our points. Now the problem says, graph your system of equations. So even though system shows up for every 6-point question I've seen in recent history, they're sometimes going to ask you to graph it, sometimes ask you to solve algebraically. So we do need to do a few of these problems so you see how it can appear differently. So this time it's asking us to graph. Well, in order to graph, we need these equations to be in y equals mx plus b. Then you can either put them in your graphing calculator or just use slope and y-intercept to graph, whatever you prefer. So one of these equations is already in y equals mx plus b form, right? Y equals 2x. So as a matter of fact, let's go ahead and graph that one first. So to graph the equation y equals 2x, I'm just going to rewrite this as y equals 2x plus 0 so that it's very obvious to us what the y-intercept is, right? So now it's in y equals mx plus b. So my y-intercept is 0, so I'm going to go to 0 and plot my first point there. And then I'm going to use my slope, which is 2 over 1. And I'm just going to use that slope to build my line. So I'm going to go up 2 units over 1. And that's going to have me right here for my second point. Up 2 units over 1. And I'm going to continue, and I'll fast forward through this to just build my line. All right, so my line y equals 2x is done. And now let's go back up, and we're going to have to do some work for that first equation. So in order for me to graph 2x plus 1.5y equals 30, I have to get this into y equals mx plus b form. So I want that y to be isolated. So I'm going to first subtract 2x from both sides. That's going to give me 1.5y equals negative 2x plus 30. You could have written 30 minus 2x. I'm writing it like this so that it's obviously in y equals mx plus b form. Now, again, I want that y isolated. Right now, it's being multiplied by 1.5. So I'm going to divide by 1.5. And remember that when we divide, we have to divide every term in the equation by that number. So now on the left side, I do have y isolated. And on the right side, I'm going to get negative 4/3 x plus 20. All right, now I have this equation in y equals mx plus b form. So now I can go graph it because I can see that my 20 is my b, my y-intercept, and negative 4/3 is my m, or my slope. So let's go ahead and get to 20 on the y-axis. And we're going to start our line there. And now we're going to use our slope, which was negative 4/3. So I'm going to go down 4 units and then over 3 units to plot the second point on my line. And I will go ahead and fast forward through this again as I build this line. All right, so both of my lines are now graphed, and the question is asking me to state the coordinates of the point of intersection of my line. So the point of intersection just being this point right here where both lines meet, where they both cross and go through. So my x coordinate is going to be 6. And the y coordinate is going to be 12. So they intersect at 6, 12. But because it's a word problem, you always want to write that in the context of the problem itself. And so because 6 is my x and 12 is my y, let's just look at what those represent. The x-axis represents the number of balloons. So that means that 6 is the number of balloons. It's 6 balloons. And then 12 is on the y-axis, and that was the number of party hats. There is the full 6 points for this question. Now we're looking at the August 2024 Regents, and the 6-point question is yet again a system of equations word problem. Jen joined the fan favorite movie club at a local movie theater. At this theater, the cost of admission in May and June remains the same. In May, she saw 2 matinees and 3 regular price shows and spent $38.50. In case you're wondering, a matinee is just a daytime show that tends to cost less than a regular show. And then it tells us that in June, she went to 6 matinees and 1 regular price show, and she spent $47.50. And it wants us to write a system of equations to represent the cost M of a matinee ticket and then the cost R of a regular price ticket. So we are tasked with writing a system of equations. That means that we are going to write 2 equations using the 2 variables that they gave us, and we're going to translate the important information from that problem into math. So let's look at the first important piece of information here. It's what I have highlighted in blue. It says that the cost of 2 matinees plus the cost of 2 regular tickets is $38.50. Let's translate that into math. So we are told that the cost of a matinee ticket is represented by the variable M. So if M represents the cost of 1 matinee ticket, and I am now talking about the price of 2 matinee tickets, then I'm going to represent that part of the sentence with 2M. So whatever the cost of 1 is, which is M,
If I multiply that by 2, now I have the cost of 2 matinees, all right? Now, she went to both of these shows, so that's why we are adding these costs together. So now it tells us that she went to 3 regular shows. Well, if the cost of one regular show we're calling R, then the cost of 3 regular shows we're going to call 3R, because 3 times the price of 1 gives us the price of 3 of them. And then it says that all together is, which in math is always going to be an equal sign, $38.50. And just like that, we already have one of our equations written. Now let's look at the orange highlighted piece to create our second equation. The cost of 6 matinees. So again, one matinee cost is represented by M. So 6 matinees will be 6 times the price of 1, 6M. Plus the cost of 1 regular ticket. So that's R or just 1R, either or. And that altogether is costing us $47.50. And just like that, we already have 2 points on this question because we correctly translated the English into math. This is the most important part of these types of problems, because if you have the wrong equations, you're going to have the wrong answer at the end. Second part says, Jen said she spent $5.75 on each matinee. Well, the price of each matinee we've represented by the variable M. So that means we're saying that M is equal to $5.75. And $9 on each regular show. Well, again, we call the cost of each regular show R. So that means that Jen is saying that R is equal to 9. Is Jen correct? Justify your answer. Always check to see how many action items you need, so we're collecting all the points we can get. So we're going to have to answer 2 things here. We're going to have to answer whether or not she's correct, and then we're also going to have to make sure that we justify our answer so we can get all the points for this part of the question. So the way we know if she's correct is we're going to go back into the 2 equations we wrote, and the values that she's saying M and R are, they have to make both of these equations that I'm highlighting true. That's how you know if variables' values are truly the solutions of the system. They have to make both equations true. So we will start with 2M plus 3R equals 3850, and we are going to substitute. So instead of writing M and R, we're going to write the values that she gave us, which are right here. 575 for M. I'm going to multiply that by 2 plus 9 for R. And we're going to go ahead and just evaluate this whole left side. And when I do that, I'm going to get 3850. So I do get a true statement. However, we haven't answered the question because, like I said, these 2 values have to make both equations true. So we do also have to try into this second equation. So instead of writing M, once again, I'm writing 575. That's going to get multiplied by 6 this time. Instead of writing R, I'm writing 9. And again, I'm going to evaluate the left side of this equation. And when I do, I get 43.5, which does not equal 47.5. And because it does not equal it, the answer to my yellow question is no. Jen is not correct. Now, showing this does not equal symbol is enough to justify our answer of no. But if you want to be more thorough, you can write a little sentence somewhere that says, no, she's not correct because her values don't satisfy both equations, or her values don't make both equations true. The last part of this says, use your system of equations to algebraically, meaning by substitution or elimination, determine both the actual cost of each matinee ticket and the actual cost of each regular ticket. So we can do substitution or elimination. I'm going to choose to do elimination for this system. I'm going to multiply this bottom equation by 3 so that I can get the coefficients of R to be the same. So when I distribute that 3 out to the whole equation, my new equation is going to become 18M plus 3R is equal to 142.5. All right, I'm going to bring over my top equation. And now because my coefficients of my variables are the same, what I'm going to do is subtract these 2 equations from each other, because when I do that, 3R minus 3R will eliminate. It'll cancel out, right? So I have 2M minus 18M. That's going to give me negative 16M equals 3850 minus 142.50 is going to give me negative 104. I'm solving for m, so I'm going to divide by negative 16 on both sides. And that's going to give me m equals 6.5. So what I already have, what this means, the cost of each matinee ticket is $6.50. But I'm not done because it's asking me to find the cost of each matinee ticket and each regular price ticket. So now I'm going to take this value of m that I have here, and I'm going to substitute it into either of these equations for m. It doesn't matter which one you choose. So I'm going to go into the bottom equation, and now instead of writing m, I'm going to write 6.5 because I already know what m is. I found its value. All right, now we're going to multiply and get 39 plus r is equal to 47.5 or 50. Subtract 39 from both sides, and we're going to get r equals 8.5. And so what this tells us is that the cost of each regular price ticket is $8.50. Now, technically, I could have done this last part first and then just used all my math here to prove that Jen was wrong in the second part. So you could have solved the system first, and then in this second part right here, to justify that she was wrong, you could have just said she's wrong because the actual prices of the tickets are $6.50 and $8.50. So either way you do it, you would have gotten full credit. So there are your 6 points on this question. Now we're in the June 2024 test. Again, back at the 6-point question. So hopefully you believe me by now and you see that the 6-point questions all look very similar. It's another word problem that deals with system of equations. Courtney went to a coffee shop to purchase lattes and donuts for her friends. One day she spent a total of $15.50 on 4 lattes and 2 donuts. I almost feel like they purposefully wrote out the 4 and the 2 so that if you're someone who's just scanning word problems really quickly for numbers, that you don't see that. So just one more reason to read really carefully. The next day, she spent a total of $18.10 on 3 lattes and 5 donuts. All prices include tax. If X represents the cost of 1 latte, so X is going to be the cost of a latte, Y represents the cost of a donut, write a system of equations that can be used to model the situation. So once again, pulling out that important information, my first highlight in blue tells me that the cost of 4 lattes and 2 donuts is $15.50. Now, I'm already told that the cost of 1 latte is represented by X. So if 1 latte costs X, then 4 lattes are going to cost 4X. Now she's buying lattes and donuts, so I'm going to add these things together because she's paying for both of them. The cost of 1 donut is represented by Y, then the cost of 2 donuts is represented by 2Y. And her total that day was $15.50. And just like that, I have my first equation done. Second important piece of information was that the cost of 3 lattes and 5 donuts is $18.10. So again, the cost of 1 latte is represented by X, so 3 lattes are 3 times the cost of 1, so 3X. Plus the cost of 5 donuts is going to be 5 times Y, and all together her bill that day was $18.10. And I already have 2 points on this problem just for writing that system. Great job. Second part, very similar to the last text. Courtney thinks that 1 latte costs $2.75, meaning she thinks that X is equal to 275. Don't rush this. Go back up and find which variable represented lattes. It tells us right here if X represents the cost of a latte. So if she thinks 1 latte is 275, she thinks that X is 275. She also thinks that 1 donut is 225. So she's telling us she thinks that Y is equal to 225. Is she correct? Justify your answer. Again, 2 things to do here. Answer a yes or no, and then prove ourselves correct. All right. So just like last time, we can go ahead and substitute into both of our equations. So if we take that first equation, 4X plus 2Y equals 1550, and we're going to substitute. So she said X is 275. I'm multiplying that by 4. I'm multiplying the Y by 2, but I'm replacing it with 225. And I'm trying to see if it'll give me 1550. Once I evaluate all of this, I will get 15.5 equals 15.5. So that part is a true statement. But again, this has to work in both equations. So let's go into the other equation. 3X plus 5Y equals 1810. Again, replacing that X, replacing that Y. Sorry, I forgot to multiply this by 3. With 225, and I'm trying to see if I'm going to get 1810. When I multiply and add on the left side, I'm going to get 19.5. And 19.5 does not equal 1810, which means that Courtney is incorrect, which again, we can justify by just showing that we didn't get a true statement, like we're showing right here, or by writing it out to be really clear and saying she is incorrect because those values did not satisfy both equations, or those values did not make both equations true. So now let's find out which values do actually make both of these equations true by solving this system. So again, we can solve by substitution or by elimination. I'm going to do elimination again. However, this time I'm going to have to multiply both of these equations. So I'm going to multiply the top equation by 3 and the bottom equation by 4, because what that's going to do is give both of these equations a 12x. And so if both of them have a 12x, I can eliminate it. All right, let's go ahead and rewrite these. I'm going to zoom through this. Now that we have equations where the coefficient of one of the variables is the same, I'm going to subtract these equations because 12x minus 12x is 0, so it will cancel out or eliminate. 6y minus 20y is negative 14y, and 46.5 minus 72.4 is negative 25.9. I'm trying to solve for y, so I'm going to divide by that negative 14 that was being multiplied by it, and that's going to give me y equals 1.85. Now go back and let's remember, what did y even stand for? So let's go back to our word problem and find that out. Y represents the cost of one donut. Really important to make sure that you know what you just found. So because y is the cost of a donut, the cost of one donut is $1.85. So here is one part of this last question, and now we still have to find out what the cost of a latte is. So let's take our donut price. Let's pick one of these equations. It doesn't matter which one. And we're going to replace y this time with 185 because that's what we found out is the value of y. All right, now we're going to multiply. It's going to give me 4x plus 3.7 equals 15.5. I'm subtracting 3.7 from both sides. That's going to give me 4x equals 11.8. Finally, I'm going to divide by 4 on both sides. And that's going to give me x equals 2.95. But now again, to put it in context, the x represented the price of a latte. So we're going to write cost of one latte is $2.95. And there we go. 6 full points on this problem as well.